Hello, today we're talking about Unit 5, Urban Land and Water Use. We're talking about the ninth unit here, ninth ed puzzle. We're going to be talking about urbanization and reducing urban runoff, sections 510 and 513. Urbanization involves a city like this where you're moving away. This is Minneapolis, St. Paul, where up around where I'm from, and you can see it. Definitely, it's not in agricultural regions. It's grown into an area like this where it's completely different. People have changed what they're doing. You can see how they've modified the water, how they've modified the land, and so forth. What your objectives here is to describe the effects of urbanization on the environment and describe the disadvantages, advantages, or unintended consequences of trying to bring it back to where it was. So urbanization means removing the vegetation to convert the land to city, which is an urban. This means we replace the soil, vegetation, and wetlands with impervious surfaces such as concrete, asphalt, or cement, which means water is not able to go down, infiltrate into the ground. So for example, here, if you look in the natural, 40% of all rain is evaporated back up so it can be recycled. 10% runs off into the streams, and 50% goes down into the groundwater so that it can be used by the trees, go down into the groundwater, and be used. In cities, 30% goes to evaporation, 55% is runoff, and only 15% makes it down into the groundwater. 55% because the impervious surfaces means that it is not able to go down into the groundwater. It goes into the sewers, into the streets, elsewhere. Urbanization prevents groundwater recharge, which is very important for cities because that's where we use get a lot of our water, and therefore it goes into local bodies of water. Some also involves CO2 emissions. Urbanization, such places as cement production, all the construction machinery, all the cars and trucks, deforestation, leading to the urban area where we lose the trees, which is carbon sequestration, and a lot of the trees are decomposed after they cut down. We also have large areas of landfills where we will learn later on these landfills is where decomposition, and those decomposition is where CO2, methane, and other things come out of them. Urbanization in coastal areas have other problems. We can get saltwater intrusion, which is due to we're sucking up so much water that it goes back. Instead of the groundwater being fresh all the way out to here, we're sucking so much of it out that the salt water comes back into it. Another reason why is because of global warming, where mostly due to thermal expansion due to the heat increasing temperatures, but also because of melting of the ice caps. This can lead to it because as it gets higher, it's going to be eventually go into the pipes that go up into the city. Trends in population over the last 70 years. You can see between 1950 and 2000 that originally we were mostly rural, and now we're mostly suburban. Overall trend is to go from the rural to the city. When people move from the rural to the city, it's oftentimes for jobs, entertainment, or cultural attractions. The urban areas are more densely populated, meaning that you don't have to drive as far to get to work. Therefore, there is a decreased environmental impact. However, if you go over here, we're going now to suburban. What happens there? There are less dense areas surrounding the urban area, such as La Cañada, Forest Hills, other places. And then eventually, urban areas can become megacities. A megacity are cities over 10 million people. In 1980, there were only 5 megacities worldwide. In 2016, and now there are 38 megacities. There are also something called a megalopolis. It's when a group of two or more adjacent metropolitan areas are so close that you can't tell where one stops and one starts. And you can see along the East Coast, it's almost the entire East Coast. In Japan, you can see where it's almost a constant city by looking at the lights. Urban sprawl is where population moves from out of the dense area to the suburban areas such as Long Beach or La Cañada. The cause is it's cheaper to own land, and you get a larger home, and you get place to play. It makes it cars have made it much, much easier. In fact, one of the types of cities involves having a cars. If you look at New York City versus LA, New York developed when there were no cars. LA developed when there were, and therefore it is much more spread out. Because the people leave, you want to leave also because none of your neighbors are left around. Because there are fewer residents, there's less tax revenue, and therefore there's fewer city services. Also, because the residents are leaving, businesses follow. A lot of places in ghetto areas, there is no supermarkets. They have no place to get a lot of their food. These abandoned foods in these areas become unsightly. They become run down, and therefore it becomes uglier and uglier, and therefore more people move. Some of the urban sprawl causes is the extensive highway system. When we got 14 and then such as that, more and more people were moving up to Santa Clarita and Palmdale area. Increasing driving increases fuel tax revenue, which means we can build more highways. Highway expansion makes it easier and easier to commute from the suburbs to urban areas. Some of the solutions to that is, let's make it so you can't go beyond a certain distance. Let's make public transport feasible and make it a city where you can walk or ride your bike. Let's have mixed land use where you have residential, business, entertainment in the same building, all located within the same area. So practice question 5 for this unit. Describe a possible solution to the issue of urban sprawl and identify one of the possible economic consequences of your solution. Urban runoff. So this learning objective describes the methods of reducing. Mitigating means reducing problems related to urban runoff. Can you identify a research method, design and measure that method? So what are some of the environmental consequences of urban runoff? There's decreased infiltration, water getting down into the groundwater. And like we said before, only 15% makes it into the water in cities, whereas 50% gets into the groundwater in rural areas. Rain washes the pollutants into the storm drains or into the streams. And when that happens, it just goes out and pollutes the area. Pollutants effects. You've got salt coming off, which can cause plant and insect death. We can have sediment, which causes turbidity. In other words, out in where LA River goes out, there's going to be an area where you can't see very far. You got fertilizer going out from all the fertilizer that we're doing onto our lawns, causing eutrophication. We've got pesticides that let's get rid of, use that Roundup to get rid of all those plants we don't want, or let's get rid of the insects, and so forth. A solution to that is to use permeable pavement. These are designed to allow stormwater to go down into the groundwater. And so what happens is instead of being solid, it has holes down through it. And then it's got bigger and bigger rocks underneath it so that the water can go down into the groundwater. It decreases runoff, decreases pollutants into the streams, and storm drains. Decreases the likelihood of flooding into the river. When I first moved to LA, it was an El Nino year. And whether you believe it or not, the LA River down by the 5 and the 134 flooded. However, the problem with all this is it's more costly than traditional pavement at this point in time. Solution, so let's have rain gardens. So along the streets in urban areas, let's put a garden right next to the road. It decreases runoff by allowing it to soak into the soil. And it's pretty also. And this goes down into the groundwater and creates a habitat for pollinators, sense of place. Another solution we can use is public transport. The more cars in the road, more pollutants on the street, and more into the storm drains and local waters, such as motor oil, tire pieces, oh my gosh, gasoline, antifreeze, all these nasties. The more cars, the more lanes and parking lots that are required. In other words, we have to go from a 4-lane to a 5-lane to a 6-lane on each side. When we do that, there's more and more runoff. Public transit reduces the urban runoff, pollutants, and so forth. If we look here, these are the same number of people. If we got into a public transit, we'd have that one vehicle. If we individual in cars, and I don't know when's the last time I saw someone during rush hour in the car with someone else, we'd have to have the same number of people would be in that many vehicles. More roads are needed. So let's build up and not out. If we do up instead of out, we decrease urban runoff. So this city, Atlanta, Georgia, is 5.2 million. This Barcelona is the same population. However, here we've got urban going out to suburbans and so forth. Here we don't. They're all in one area. We have an urban area of 4,280. Here it's only 162. Transportation, carbon emissions is almost 15 times as much here as what it is in Barcelona because you don't have to drive as far. Combined with green roofs or rooftop gardens to further decrease the runoff. Here what you do is you basically plant trees all over the place on your roof. It decreases the amount of air conditioning you need. It keeps you warmer, decreases the amount of runoff and other problems. Also sequesters CO2. It also sequesters nitrous oxide, particulate matters, and other things because the plant mouth, the stomata, store it in their tissues. Okay. And so we get rid of the particulate, we get rid of all those other things that are really nasty. This is New York City, looking down from one of the highways, and we're already getting greening of the roofs in New York City. Practice FRQ 5 for this unit. Design an experiment, an investigation to measure the relationship between the number of trees in the city and the amount of storm runoff the city produces. Propose a hypothesis. Outline a procedure for your investigation. Identify your independent variable and your dependent variable. Questions?